Okay, your properties of exponents. You're going to have a few that I have listed. You're not going to get these formulas. You don't get formulas on the SAT, so that's why we don't give you formulas for your tests and quizzes here, okay? Your zero exponent property tells you basically anything to the 0 power is 1. Whether it's a number, whether it's a variable, no matter what it is, the answer is 1, okay? Now, 0 to the 0 power is undefined, but anything else to the 0 power is 1. So, if I have 4 to the 0 power, that's 1. If I have a negative 4, notice it's in parentheses, to the 0 power, that's 1. If I have 5 million to the 0 power, that's still going to be 1, okay? But this says if I have negative 4 to the 0 power, that's a negative 1. So what happened, what's the difference between these two examples?
One of them is, for one of them, they are multiplying everything by negative 1, including the power, and the first one is they're just multiplying the negative 4, the 4 by negative.
Okay, so notice that negative 4 here is in parentheses. That's your base, okay? But like she said, you've got a negative that's being multiplied right here. If it is not inside parentheses, then that 0 only goes to what's directly in front. So that 4 to the 0 power is absolutely 1. But my negative is on the outside of that, and so that's how you get a negative 1. You're going to have to be careful, and you're going to have to know when is it part of my base, when is it not. Okay? That means when you type it in your calculator, you better be careful, and you put those parentheses when you need them. Okay? Now, if I have a to the 0 power, that's still 1. X to the 0 power, still 1. Okay? Now, we also have negative exponent property, and pretty much what it's saying is that a to the negative n is the reciprocal of a to the n. Okay? All a negative exponent is going to tell you is that it's in the wrong spot. Okay? Meaning numerator versus denominator. So my formula tells me if I have a to the negative n, that is equal to 1 over a to the positive n. So I changed position and it became positive in the denominator. Alright? So if I have 4 to the negative 2, well, that's a negative exponent. I need to put that 1 over 4 squared. Now, if you have a number as your base, okay, you got a base raised to an exponent. Okay? If you have a number as your base, you have to evaluate it. So I would have 1 over, what's 4 squared? 16. Okay? So if I had x to the negative 3, I need to rewrite that, make that x positive by changing its position. It becomes 1 over x to the third. Okay? So anytime you have a negative exponent, you just have to move the position. Okay? Now, what if I had 1 over x to the negative 4? Well, it's negative in the bottom. It doesn't matter where the negative is. It's wrong. It's in the wrong position. So if it's negative in the bottom, I'm going to move it up to the top. That's just an x to the positive 4. Okay? So when you move its position, numerator versus denominator, you're going to make that exponent positive. Okay? It does not make the whole term negative. A negative exponent does not make the base negative. So you're going to have to separate the two. Okay? Now there's a product of powers property where if you are multiplying a to the m times a to the n, I add my exponents a to the m plus n. So what that's telling me is if you multiply like bases, you add your exponents. Alright, so if I had x cubed times x to the 4th, I would add my exponents, 3 plus 4, to give me 7. Okay? If I had 3 squared times 3 to the 4th, they're both 3's as my bases, so I would add 2 plus 4 is 6. Now it's a number as my base, right? So I have to evaluate it. What is 3 to the 6th power?
729.
Thank you. Okay. Now, what about if I divide? This rule isn't written, but if I have x to the 5th over x cubed, do you know what we would do with those exponents? Subtract. If I multiply like bases, I add my exponents. If I divide like bases, I subtract 5 minus 3 to give me 2. That rule is if I have a to the m over a to the n, then I have a to the m minus n. That's what that rule is. Okay? Now, if I have power of a product, that means if I have multiple terms being multiplied, and all of that is raised to an outer exponent, what's going to happen is you're basically distributing that outer exponent to the existing exponents. Okay? So if I had 2x in parentheses cubed, then everything would take that 3 as my exponent. So it becomes 2 to the 3rd and x to the 3rd. Okay? And 2 to the 3rd becomes 8x cubed. Okay? Now there's a power to a power if I have x to the 3rd raised to the 7th. If I have an exponent raised to another exponent, do you know what I do with those exponents? You multiply. So it becomes x to the 21. Y'all remember that?
Yes.
Some of y'all. Alright, so if I had x squared y to the 5th all raised to the 3rd.
You multiply each one by the 3, so that'd be x to the 6 and x to the 15.
Y to the
Y
15th.
to the
Yes. Okay, so you distribute that outer exponent and you just multiply exponent and exponent. You cannot multiply base and exponent. You're going to have to keep those separate in your head. Okay? Now, power of a quotient is the same as this. It's just fraction form. Okay, so if I have 3 over 2 all raised to the 5th, you're still distributing that outside exponent to each term, whether they're multiplied or divided. Okay? So that becomes 3 to the 5th over 2 to the 5th, and then you would evaluate whatever that is. Okay? Say that again.
243 divided by 32.
Thank you. Okay? So if I had x to the 7th over y to the 4th, all raised to the 2nd power, I would take that outer exponent and distribute, so that becomes x to the 14th over y to the 8th. Y'all following me? So we're going to do a lot of examples, okay? And each example could be different. Some are easy, and then that starts picking up, okay? So here I've got 2 to the 5th, 2 over 5 raised to the 3rd. I am not typing that in my calculator. I am doing what?
You're distributing.
I'm going to take that outer 3, and that becomes 2 to the 3rd over 5 to the 3rd. I expect to see that middle step. And then evaluate. 2 to the 3rd is 8. 5 to the 3rd is 125. Then I check, can I simplify 8 over 125? Well, no. Okay? But if you're not sure, in your calculator, you can set up the fraction. So 8 over 125. Get out of the fraction and hit that simplify button. It'll stay the same if you can't simplify. Okay? Alright, my next example is 2 raised to the negative third, all of that raised to the second power. So I take that, it's a power to a power, and I multiply.
So it's a -6.
Okay, but I have a negative exponent.
And then you gotta put 1 over it.
1 over 2 to the 6. Now, when you evaluate, I would not type 1 divided by 2 to the 6 because it's going to give you a long decimal. Do 1 over and just type in what 2 to the 6th is.
1/6.
You understand what I mean by that? Alright, now here I've got -3, and then I have -3 squared. What is happening with this first -3? What's my exponent? If I don't have one written, it's understood to be a 1. And then what operation is happening between those -3's? So what do I do with my exponents? Add them. -3 to the third. Notice that the negative is part of my base. So you type it like that. All good so far? Do the next one. Hopefully you distribute. You get 3 to the -2 over 4 to the -2. But I have negatives. So this 3 to the -2 needs to come down, and that 4 to the -2 needs to go up. Wherever it's negative means it's in the wrong spot. It needs to go in the other spot.
So it's 4 squared over 3 squared.
Which is 16 over 9. Alright, now this next example, I've got 2 to the third power over 3 to the -4. Are those like bases?
No.
No. I got a 2 and I got a 3. Those are not like bases, so I can't subtract those. But I do know this 3 to the -4 is negative. So it needs to come up. But does the 2 to the third need to move? No. So 2 to the third times 3 to the fourth. I no longer have a fraction. So 8 times 3 to the fourth is
81.
8 times 81.
648.
Y'all good with that? Do we have questions before we move on? Okay, now I've got variables instead of just numbers. I'm still going to treat it the same way. I have y to the fourth raised to the fifth, a power to a power. What do I do? Multiply. When you have bases being multiplied, that's when you add your exponents. But when you have an exponent raised to another exponent, you multiply y to the 20th. So now I've got 2y cubed raised to the second power.
It's going to be 2 squared y to the 6.
So I'm going to distribute that outer 2. So if you needed to see the first example, like you're distributing that 5 to become 20, you can do that too. If you see it better that way. Alright, now I've got -5x squared y to the fourth, all raised to the third. So that 3 is going to go to the -5, the x squared, and the y to the fourth. Okay, now is that negative part of my base?
No.
Yeah, it's part of my parentheses, so it's going to stay in parentheses negative 5 cubed, then x to the 6th and y to the 12th. So my final answer would be negative 125.
X to the 6, y to the 12.
On the worksheet, if we don't include the middle step, will we get points off?
On something as simple as that, no. But if you go straight to, like, one of these, straight to your answer, then something on a quiz or a test I would take off because I want to see that middle step when you have numbers. So your variables, there is no middle step. It just is what it is. All right, 3x squared y to the 4th raised to the negative 2. You can do two things. You can distribute that negative 2 to everything, or I could automatically do what? It's whatever you want to do, okay? If I recognize that I have an outside negative, and when I distribute, I know they're all going to be negative, I can recognize that I'm going to put 1 over 3x squared y to the 4th squared. But if you like to distribute first, then distribute first. You'll just have to flip everything at the end. Okay, so here,
The answer is 1 over 9x to the 4, y
okay, before lunch, y'all finish this. Do we have questions so far? Okay. So then, if you could do all of that, we're going to apply now the fraction properties of, if I have like bases, what am I doing with these exponents?
Subtracting.
So this becomes x to the,
Third.
okay, something like that. You either got it or you didn't, okay? It's really hard sometimes to give partial credit. Well, there would be no partial credit for something like that, okay? But when you have x to the 5th over x to the 9th, you know you're subtracting. You subtract top minus bottom, okay? So this would be 5 minus 9, which is,
X to the negative 4.
okay, I would need to see that before you make it what?
1 over x to the negative x.
1 over x to the 4th. Are we good with those two? Okay. Now, this next one, do I have like bases?
No.
No. How many different terms are there?
3.
Okay. So I take this 4 and I distribute it to all 3. So is the negative part of my base?
Yes.
Yes.
So I've got negative 2 in parentheses to the 4th, x to the 4th over y to the 4th. What is negative 2 to the 4th?
16.
So 16 x to the 4th over y to the 4th. Be careful with that. If you did not type it in parentheses, you would get a negative 16, which is wrong. Okay? Do the next one. Okay, I would distribute. So what do I need to do?
Take y to the negative 9 and put it on top to get rid of the negative. So it'd be x to the 6 times y to the 9.
Why did I move the y and not the x?
Because the x was already positive.
Mm-hmm. So just because you move one doesn't mean you have to move everything. Okay. Now, if I'm looking at example 5, what do you notice?
That it's,
Three letters.
oh, there's the same variables on both sides.
Oh, there is some three letters.
X and there's an X on top and an X on the bottom.
So inside my parentheses, I have 2 terms that are like bases. I am going to clean that up before I distribute. Do you have to? No. But at one point you're going to have to. Okay? I like to do it at the beginning. And so what I'm doing is I'm taking this -4 and leaving it. But I've got x squared over x cubed. So I'm subtracting. 2 minus 3 gives me -1. So whenever I'm doing that, it's got a negative. So where should it end up?
On the top.
If I am just doing top minus bottom, that x to the -1 would be what goes in the numerator. So if it's negative here,
That'll be possible.
it needs to come to the denominator, right?
Mm-hmm.
So that x to the first goes to the denominator. And then I have z squared raised to the third. So if you are cleaning up something and you're simplifying and it gives you a negative exponent when you subtract, then you're putting that in the denominator. If it gives you a positive, if it would have been x to the 5th over x to the 3rd, and I would have gotten x squared, that stays in the numerator. Okay? Alright, now that I've cleaned it up, I can distribute that outer 3. And so I have -4 in parentheses to the 3rd power over x cubed z to the 6th. And then -4 to the 3rd power
-64.
My z's have lines through them, so if you're wondering what that is my z. My z's and my 2's used to look alike, so that's why I do that. Okay, do you have questions over that? Okay, we're going to take it one step further. When I have something like this, there's a lot going on, but there's really not. If you separate term by term, then you're looking at -3 over 27. You're separating your x's, separating your y's, and separating your z's. Okay? Can I simplify -3 over 27? What is it?
1 over 9.
-1 over 9. Alright, so if I put my little -1 over 9, then I move on to my x's. I'm only looking at x's. And I'm going to write it over to the side. I've got x cubed over x cubed. 3 minus 3 is
0.
x to the 0 is just a 1. I don't even have to worry about it. It's the same exact thing. It cancels to a 1. Okay? Now I've got y to the 2nd over y to the 6th. So I'm subtracting 2 minus 6. And what does that give me?
-4.
Y to the -4. So where should that really go?
It should go on the bottom.
It's negative, so it goes on the bottom. It'll be positive on the bottom. And then I have z cubed over z, so I've got 3 minus what?
1.
So z
6 squared.
squared. Now that's positive, so that stays in the top. So you can leave it like that. If I have something similar to this on the answer key, I'm not going to have the 1. You don't have to rewrite it. I'm just letting you know if you put a 1 there, it's okay.
So most of the time there's going to be
it's negative because you had a negative 3 over 27.
So what is negative, the entire thing or just the top? Top.
It doesn't matter. Think about if you had 3x squared divided by x squared. What would happen? X squareds cancel, leaving you with 3. So if it's the exact same thing in the numerator and denominator, it just cancels to 1. Alright, example 2. 16x to the 4th y to the negative 5 over 2x to the negative 3 y to the negative 2. Okay? You can do different things. I can do one way, you can do another way, and we still get the same answer. Okay? I personally like to just start simplifying. I don't move my negative exponents until the end. If you want to move your negative exponents and then simplify, you can. I just don't prefer to do that. Okay? So if I split it into sections, I've got 16 divided by 2, which is what?
8 over 1.
So I just really need the 8. And then I've got x to the 4th over x to the negative 3. You have to be careful. Alright? This is 4 minus negative 3. A lot of people will mess this up, thinking the negative is your minus, but it's not. You're subtracting a negative, which turns into positive, so this is x to the 7th. It's positive, so where do I put it?
On the top.
Top. And then I've got y, negative 5 minus negative 2. Just negative 5 plus 2.
-3, because on the bottom that's a.
Very good. Y cubed.
You're welcome.
There's my answer. Okay, we okay with that? Alright, now I've got a multiplying problem. I'm still doing term per term. So 2 is going to be multiplied by, and that gives me, and then I've got x to the 3rd times x to the 4th.
That'd be 3 plus 4. X to the 7.
I'm going to add those exponents, x to the 7th. And then y to the 3rd times y squared. I'm going to add those. 3 plus 2 gives me 5. So you use every property you need to, but you're going to do is like base. Yes.
Would we FOIL that?
Because it's technically one term. You don't have a plus or minus anywhere. So there's nothing to do first, outer, inner. You just multiply its like part. So if you needed to rewrite it to x cubed y cubed times negative 5 x to the 4th y squared, so you don't get mixed up with those parentheses, you could. Alright, now the inside of these parentheses is exactly what you did with 1 and 2. It doesn't look like it, but that's exactly what you did with 1 and 2, and I just have an outer exponent. So I will always, when I have something like this, I will simplify first, always. Okay? What happens is people know to simplify, but then they forget that they have an outer negative 2. You cannot do that. Alright, so I set up my parentheses with my outer exponent. I set up my fraction. And I separate my terms. 5 over 2. Can I simplify that?
No.
So it's going to stay. Then I have x cubed over x to the negative 1. So I have 3 minus negative 1.
So that'd be 3 plus 1.
So does that go in the numerator or the denominator?
Numerator.
then I have y negative 2 minus 5. Goes in the denominator. Hopefully you're making it positive when you put it in the denominator. And then z over z to the 6th. That exponent is understood to be 1. So 1 minus 6 is a negative 5. Z to the 5th in the denominator. So I cleaned it up. Now I need to distribute. So 5 to the negative 2, x to the 2 to the negative 2, y to the, and z. Very good. What happens? So every exponent became negative. So this whole denominator needs to go up, and the whole numerator needs to come down. So I'm going to do that and evaluate my numbers at the same time. 2 squared is 4. Y to the 14th, z to the 10th, over 25 x to the 8th. Do you want to try one before we move on? One from your worksheet? Let's say do number 22 from your worksheet, and we'll check it. Does 2 over 3 simplify?
No.
If I have a cubed over a squared, what do I have? Just a to the first. B to the negative 1 over b squared.
It's gonna be B.
So b cubed in the denominator. All to the negative 4.
Yep.
Distribute.
2 to the negative 4, A to the negative 4 over 3 to the negative 4, B to the negative 12.
Very good. But then,
We would all switch them over at the same time, simplifying the 2 and 3. So the answer is 81, B to the 12 over 16, A to the 4.
how do we feel about that?
Simplify it. 81, 16.
It won't. I don't think. Did we get it right? Did we know how to do it? If you didn't get it right and just make a minor mistake. Alright. Moving on. What if now I have an equation and I have a variable as my exponent? So what I need to happen, I need my bases to be equal for my exponents to be equal. Okay? So I'm going to use my properties of exponents to get it down to one term on the left raised to an exponent and one term on the right raised to an exponent. So base exponent equals base exponent. Okay? So if I'm looking at my first example, x to the 21st power equals x to the 4r power and then x to the 5th power. What's happening here?
No idea.
I'm multiplying my bases. So what do I do with my exponents? I add them. So I'm going to have x to the 21st power equals x. If I take 4r and add 5, can they combine?
No.
So it's just 4r plus 5. If you have two things equal, if my bases are equal, then that means my exponents are equal. So they are both x's. So I'm able to set 21 equal to 4r plus 5. Now how do I solve for r?
You gotta first
Subtract your 5. So then 16 is equal to 4r. Divide by 4, and r is equal to 4. Okay, but what if, like example 2, my bases are not equal? I will give you something that can be manipulated. Okay? What's my base on the left of example 2? 2. So I need to make 64 become 2 to the what power? Okay? So I'm going to copy down the left side. I know it's going to be 2. If you don't know 2 to the what power gives you 64, just start typing in 2 to the 3rd, 2 to the 4th, 2 to the 5th until you get 64. So it should be
2 to 6.
So all I did was manipulate 64 to become 2 to the 6. Now I have like bases. So that means 3r minus 3 is equal to 6. Add your 3, and 3r is equal to 9. Divide by 3, and r is equal to 3. You understand that? Okay. So then 4r plus 2 equals 16, 3r plus 2. Can I manipulate 16 to become 4?
Yes.
Okay, so 4r plus 2 is equal to 16 is 4 squared. And that is raised to the 3r plus 2 power. Now, what happens when I have a power raised to a power? I multiply. So I am multiplying 2 times the entire 3r plus 2. So 2 times 3r, and then you can't forget 2 times 2, which is 4. So r plus 2 equals 6r plus 4. How do I solve for r?
Subtract 2.
You can do it either way. If you want your r's on the left, constant on the right, you'd subtract 2, subtract 6r. If you want your r's positive, move it to the right, move your constant to the left. You want your constant and variable separate. Okay? I move my variables to the left no matter what. So negative 5r plus 2 equals 4. Subtract your 2. Negative 5r equals 2. So r equals
Negative 2.
okay. Next example, what do I do?
Distribute 3 to the x squared of x.
Okay. So if I did that first, it becomes x to the
6.
and x to the
3r.
and then what do I need to do?
Add them.
I'm multiplying x and x, so I add 6 plus 3r. Subtract your 6, and 3r equals, divide by 3. Do you know how to do the next one?
Yes.
Try it. What do I do?
First thing you subtract 4. You subtract negative 2r from 4r, which would mean you add 2r. So it'd be x 6r.
You're showing 4 minus negative 2r. So then 6r equals 30. So when you're doing your work, I want to see what your equation is for your like bases, what your exponents are set equal to each other, and then whatever work needed to get your answer. Okay? Do we have questions? You will have a quiz over this next class. Okay, so Thursday you'll have a quiz, and then we'll do 6.1. This is like an introduction.